Right, so we are saying if a matrix A has m rows and n columns, we call A what m by n matrix. We refer to m by n as the order of what the matrix. In general, a typical m by n matrix A may be written as this. So we are saying the dimensions for you to be able to know the dimensions of a matrix. We have a okay. So for you to be able to know the dimensions of a matrix, we have m to be what rows and n to be what columns. So when you see the matrix like this, you just count the number of rows and the number of what columns, and that will give you your dimensions. So when we count these ones, we have 1, 2, 3, 4. We have 4 rows, right? When you count the columns, we have 1, 2, 3, 4. So we have how many rows? So this one, 2, the columns are also 4. So when you want to give a dimension for this matrix A here, you are going to get it as what? 4 by 4 matrix. So the first one must be what? The number of rows, and the second one must be what? The number of columns. And when you count this particular matrix, the number of rows are 4, the number of columns are 4. So the number in the ith column, ith row and jth column of A is called the ij element of what? A, as written in this. So all what they are trying to say is that for you to be able to locate a particular element in a matrix, you have to know where that element can be located. So when you talk about this particular element, it can be found on where? The first row and what? The fourth column. So this is the first row, and this is 1, 2, 3, 4. The fourth column. Do you get it? Do you get the dimensions? So when you have something like this, so let's say if the matrix is 2, 1, 3, 4. All right. So this one, you count the number of what? You want to know the dimensions of this matrix. You count the number of rows. So the number of rows are 1 and 2. So you write down the number of rows by the number of columns. The number of columns are also what? 2. So this one, 2, we have what? 2. So when you want to give a dimension for this particular matrix, you have what? 2 by 2 matrix. When you have something like this, I'm using mouse, so you forgive me because it's very hard to write with mouse. Okay, so who can tell me the dimensions of this particular matrix A here?
2 by 3.
2 by 3. Okay, so Andrews is saying 2 by 3. Are you all saying it's 2 by 3, or is someone having? Is it?
Yes, 2 by 3.
You are interchanging the thing. I said you first of all count the number of rows first before the number of columns, but you interchange it. So the number of rows are 1, 2, 3. That is 3 here by the number of columns 1, 2. So this one is 3 by 2 rather, not 2 by 3. Do you understand? You always consider the number of rows first before the column, because when you read the slide, it's saying if a matrix A has m rows and the number of rows are 1, 2, and 3. M rows and n columns, we have what? M by n matrix. So the M stands for what? Rows. N stands for what? Columns. So we have M by n. So when you say 2 by 2, it means the rows are 2. And the column are rather what? The columns are rather 3. But this one, the rows are 2 and the rows are 3 and the columns are 2. So we get what 3 by 2 matrix. You get it?
Yeah, we get it.
All right. Okay, what about this one? Oh, I'm using mouse to write, so you forgive me. It's not easy to write with the mouse. All right. So who can tell me the dimensions of this particular matrix? Please, if you don't understand anything, just draw my attention because it's a build-up. If you wait till we get somewhere like very far from this place, then you draw my attention to be something which is there. So if you don't get it now, kindly draw my attention so that I repeat myself or something like that. Okay, let's move on. So who can give me the dimension of this one?
I think it's 2 by 3.
Yes, this one is rather 2 by 3 because you first consider the number of rows. You first of all consider the number of rows. Secondly, you consider what the number of what columns. So this one is what 2 by 3 because the rows are 2. So we have 2 here. The columns are 1, 2, 3. Mind you, the columns are the vertical ones. So the 9 and 4 are the columns. And the rows are what? 4, 6, 5. So I always take it like this. So rows moves with what? H, horizontal. You get it. Then columns moves with what? V. That is what? Vertical. So just take this one as the clue. So when the moment you hear of row, you know you are talking about what? The horizontal one. The horizontal rectangular array. So moving in what? 4, 6 to 5. When you talk about rows, you know you are talking about what? Horizontal. That is the 4, 6, 5. Sorry. Then the columns, you are talking about the vertical. So column, we are talking about 0, 6, 1, 5, or what? 9, 4. You get it now. Can you move on?
Yeah.
All right. Let's move on. So this one is what 3 by 3 matrix because the number of rows are what 3. The number of columns are what 3. Now the moment the reason why they've written 833 is that the element 8 here is found on the third column. On the third column here, this is the third column. This is the third column, second column, first column. This is the first row, second row, and what? Third row. The reason why they've written 833 is that the 8 element here, the 8 here is found on what? The third row, and what? The third column. You get it?
Yeah.
Okay, so who can tell me that of 4? The element 4. Where can that one be found? On which row and on which column? On which row and on which column? Hey.
821.
He said
821.
821. Okay, so you first of all consider you are right, but we consider the row first. You get it? So the row is the first one, so A1 and the column is 2. So you are right, but interchange it. Always consider the number of rows before you consider the number of columns. Okay, what about the element 5? What about the element 5? Where can that one be located?
821.
He said
821.
821.
8,
821.
821. Okay, that is correct. What about the one here?
832.
A
32.
32. All right, correct. So I guess you all understand this one. So we talk about vector. All right. So back for vector. Read it for me.
God.
Back for
Hello.
back for. I'm gonna read this one for me. Or Charity, if you can read it. Read it.
Let's go, sir.
A vector. Please, I'm reading now.
Okay.
Oh, me.
A vector V of dimension n is an n by 1 matrix rectangular array of elements. V equals V1 V2 to Vn. A vector of the form V is a column vector. Into brackets, the transpose of a column vector is a row vector.
We are saying the vector is a special form of a matrix. So the vector is what? Like a rectangular array of elements. But that one, it is having only one column. And they have a number of rows. It can be 2, then the number of rows can be 2, it can be 3, it can be 4, and so on. You get it? So we are saying that the vector is a special form of matrix. So we can have 2, 1, 4, and what? 8. This is a vector. Because we are saying the vector has what? N by n. N by 1 means the n here means the rows, but the columns, they are only what? They are always 1. So this is a special form of what? Matrix. All right. So let's move on. So we are saying any m-dimensional vector corresponds to a directed line segment in the what? M-dimensional plane. Example, 2-dimensional vectors. So this one, they are only 2. So then number of rows are 2. But I'm saying that with the vector, they have only what? They has only one column. They are having only one column. So this one, if you remember back, let's say back in UGBS or SHS, you were using this as our coordinate to plot the graph when we reach the rigid transformation in that place. You were using things like this as our coordinates. So this one represents the X, this one represents the Y to plot something on the graph. So this is what they've done here. So this one is like coordinate for plotting on the graph. You get it? Are you okay with that part? Like we don't need that part. That's why I'm rushing like that. This vector and something like this, we don't really need it. The important things are there. That's the scalar multiplication, addition, and the rest. Okay, so let's move on to the scalar multiplication. Okay, Bapo.
Scalar multiplication. Let A equals Aij. Denote an m by n matrix and let C be any scalar. Then CA is the matrix. CA equals CAIJ. Yeah.
Okay, so thank you. Let me take it from here. So we are saying the AAA is what? The normal matrix. But the scalar, so when you talk about the scalar, we are talking about the non-zero scalar. The number cannot be what? 0, but it can be negative or positive. So if you remember back at JHS, you'll be given like vectors or what? Coordinate to plot, let's say 2 and 4. Then you'll be having a scalar during the transformation and those stuff. You'll be having a scalar. So let's say the scalar will be what? 4. Now, what do you think this will be? We use the scalar to multiply everything in the what bracket. So we use the 4 to multiply the 2 and the 4. So you see that the final answer will be like 8 and what? 16. So the same thing applies to this one. Here you'll be given a certain matrix, and you also given what? A non-zero scalar. So that whole number or the negative number or something like that, but the number shouldn't be 0. You use that number to multiply every element in the matrix. So you see that the matrix was A. So the elements A were here. And they what? Multiply the scalar. So the scalar was what? C. So you multiply C with each and every element in the what? Matrix. Do you get this one? So example, if the matrix was A is equal to what? Let's say 2, 4, 6, then what? 8. And you are giving a scalar as what? Let's say the scalar is 2. Now, your final answer will be this, will be like this. You'll be multiplying the scalar with the matrix. So 2 times A will be 2A. Will be 2A. So you are going to use the number 2, which is the scalar, to multiply each and every element in the what in the matrix. So it will be 2 multiplying 2. Then the same 2 multiplying what? The 4 here. The 2 multiplying the 6. And the 2 multiply what? The 8. Do you get it? So you have to be your answer. You multiply this, you get what? 4. You multiply this, you get 8. You multiply this, you get what? 12. Then the last elements, you get what? 16.
16.
Okay, so this should be your answer. So you can do it straight away. So 2 by 2 is 4. 2 by 4 is 8. 2 by 6, 12. 2 by 8, 16. So that's what we are talking about, right? Scalar multiplication. And now we are saying the important thing is that the number or the scalar shouldn't be 0. That's why we call it non-zero scalar. That's why we call it a non-zero scalar. So we multiply that one with a non-zero, let's say, digit or something like that. Yes. So it can be negative, it can be positive, but it cannot be 0. So another example, if you have something like A is equal to 3, 1, 4, 6. And the scalar is what? 3. So your answer will be like 3A will be equal to, who can do this one for me? Just mention them. All right.
You have 9.
Okay, 9.
3.
3. Okay, we are moving this way. Okay.
12.
So
18.
18. Okay, so
18.
all right. So thank you. That's it. So that's all about our scalar multiplication. So example, they have A here, they have what? The matrix A here, and the scalar was 3. The scalar was what? 3. So that's why they've written 3A. So when you cross check, you see that they've multiplied 2 by each of the elements here. So they multiply 3 by 2, 3 by 4, 3 by the 3 here, 3 by the 3 here, 6 here, 3 by 8 here, 3 by 1, 3 by 4, 3 by 5, then 3 by 6. So 2 by 3 is 6, 4 by 3 is 12, 3 by 3 9, 5 by 3 15, 4 by 3 12, 6 by 3 18, 6 by 3 again 18, 1 by 3 3, then 8 by 3 24. So actually, when you talk about scalar multiplication, you are going to use the scalar given to multiply each and every element in the what matrix. Now the elements are the numbers within the what? That parenthesis or something like that. I don't know how it's called. The numbers within the what? The bracket here. Let me say it that way. Those numbers are called the elements of that matrix. You get me? Hope the understanding is clear. If you have any question up to this point, one can ask. If you have any question up to this point, one can ask before we move on. Please, this class is a discussion something, so please be talking for me. Answer and answer. You are doing lectures or something like that. No, it's not like that. Okay. So I guess everyone understand this. Okay, so addition. We are moving on to different parts. Operation. So the addition is whereby we add two or more matrices. Now, in any of the operations to perform, right, we have a certain rules guiding those operations. So when you talk about the addition, it's simply saying that the number of rows and columns of the first matrix, that's the matrix A in this case, must be equal to the number of rows and columns of the matrix B. In simple terms, the dimension of matrix A must be equal to the dimension of matrix B before you can perform the addition. So if matrix A is having its dimension, writing with mouse is not easy. If the dimension of matrix A is having 2 by 3 matrix, and B is also having 2 by 3 matrix, this one you can add. If the A is having 2 by 2, B is having 2 by 2, you can add them. Now, take note, if A is having 3 by 2 and B is having 2 by 3, can we add this one? The third one, can we add it? Can we add the third one, this one, 3 by 2 and 2 by 3? Can we add them?
No.
Why?
Yeah?
Why?
Because their dimensions are not equal.
Okay, so here when you look through, you see that the number of rows are 3, but when you move to this side, the number of rows are 2. When you check the columns, the number of columns for A, please, who is that? Okay, thank you. So when you check this one, the A2, the number of columns are 2. When you check the matrix B, the number of columns are 3. Does not satisfy the rule of addition of matrix. So that's why they are saying that let A this and B this denote 2 m by n matrices. Then the sum A plus B is the matrix. Note the dimensions of A and B are required to be both m by n. So that's what I've explained here. Their dimensions must be the same before you can perform the operations. So any question up to this point, because I want us to take some examples and deal with how to add 2 or more matrices. I think it's almost time for this. It's 45 minutes. So it will end soon. Just use the same link to join again. I'm ending the meeting and starting it again. All right. So I'm ending it. Just rejoin with the same link.
I can't see anything. No. Hello. Hello.
Yes, I'm not talking. We are waiting for them. Okay, so I think we can move on. Because I said we should join the same link. Okay, so can we add these two metrics? Can we add A and B? Can we add the matrices A and B?
Okay, now or we should wait for them?
Is that
Are we waiting for them or we should add it now?
no? Let's continue. I'm asking whether we can perform the addition on these two matrices. Can we add them? I'm asking if we can add them or not. It's a question.
Yeah.
Now, can we add matrix A and B? Can we perform the operation as in like this one? Can we add it? Can we add matrix A and B? Can we perform
Yes.
is that
I'll go for yes.
okay? So who again? Who again? You say we can add the two matrices, and I'm asking if anyone is having like different answer or something like that, or do you all agree with me? Let me pause the recording and say something. Okay, so
No.
so we can't add, but for we can't add something like this because we said the rule for addition of matrix is saying that the number, the dimension of matrix A must be equal to what? The dimension of matrix B. Their dimensions must be the same before you'll be able to what? Add them. So this one you cannot what? Add. But when you have something like this, let's say matrix C, that would be 4, 11, 9, 8, and matrix D. Zero, 8, 0 to 1 at 9. Can we add this or not? Can we add this or hello? Can we add this?
We can add them.
Can add them because their dimensions are the same. Sorry for the writing. I'm using mouse. It's not easy to write the mouse. Okay, so C plus D. What do you think the answer would be? So you multiply the elements, like you multiply, you add them. You add. So let's say the 4 to the 2, 0 here. You add the 11 to the 2, like you add them on what? The base of what? Their position, where they you find them. So this one is on the first row. You get it? The first row, first column. So this one to first row, first column. When it comes to the number 11, it can be found on the first row by the second column. So you add it to a 2. The 2 can be found on what? The first row that's on the second column. So you just add 4 plus 0 here. So 4 plus 0, 11 plus what? 2. When you come to the second row to 9 plus what? 1 here. And what? 8 plus 9. Now your answer is going to be 4 plus 0 is what? 4. 9 plus 1 is what? 9 plus 1 is what? 10. 11 plus 2 is what? 13. And 8 plus 9 is what? 17. So you can only add a matrix or 2 or more matrices if only their dimensions are the same. So if matrix A is 3 by 2, the matrix B2 must be what? 3 by 2. If matrix A is what? 3 by 3 matrix, the matrix B must be also at a 3 by 3 matrix before you can add. And we can use the calculator to perform this operation. That one is very, very simple. But that one I'll be teaching it later. So after teaching the various operations, in the next meeting, I will be teaching how to use Microsoft Excel to perform these operations. So how to perform the scalar multiplication, how to perform the addition using the MS Excel, how to perform the multiplication of 2 matrices, how to get the inverse, how to get the like there are plenty, how to get the transpose and the rest. Now, are you okay with the addition of matrices? Are you okay with the addition of matrices? Are you all okay with the matrices?
Yeah.
Addition. Okay, one more question. So this one is Now, can we add matrix A and B? Can we add them? Can we add matrix A and B here? Hey, so no one is talking. Can we add them? Can we add them? Guys, unmute yourself and let the team be like interactive. You are making the team boring.
How is it?
I was like, can we add the matrix A and B? Can we add them?
No, please.
Eh?
No,
Why?
because they are not the same. Wait, matrix A is 3 by 2, and with matrix B is 2 by 3. Yeah.
So matrix
you
A is what? 3 by 2, right?
3 by 2.
And matrix B is what?
Matrix B is 2 by 3.
Yeah, so you always consider the number of rows first before you mention the number of columns. So this represents the rows. The 2 here represent the number of rows. The 3 here represent the number of columns. Writing the amounts is not easy. Okay, so you manage. Okay, so I think the addition is okay now. So let's move on to what? The multiplication. The multiplication of the matrix. Now, the rule is saying that for you to be able to multiply two matrices, the number of what? Columns of the first matrix must be what? Equal to the number of rows of what? The second matrix. Now, it sounds confusing, but take it easy. We are saying that for you to be able to multiply two or more matrices, the number of columns of the first matrix must be equal to what? The number of rows of the second matrix. The number of columns of the first matrix. So before we can multiply, we have to have we must have what? Two or more matrices, right? And before you can what? Multiply them, we are saying the column. And I'm saying the column, so when you hear something, let's say 2 by 3 here. The rule is the first one, column is what? The second one. So the column must be the first matrix must be equal to what? The row, not the column, must be equal to the row of the second matrix. Must be equal to the number of rows of the second matrix. Now let's take an example. Oh shit. Okay. So let's say example A1. Let's say the matrix A was what? 2 by 4. And matrix what? B is what? 4 by 3. Does these two matrices satisfy the rule of matrix multiplication of a matrix? Does matrix A and B satisfy the rule of multiplication of matrix? I'm asking a question, please. I'm asking a question. Now we are seeing that the rule is saying that the number of columns, and we are saying here are the rows and here are the what? Columns. Here are the rows and here are the columns. Now the number of columns of the first matrix. So this is the first matrix, this is the second matrix. So the number of columns of the first matrix must be equal to the number of rows of the what? Second matrix. And I'm saying with the example given here, does it what? Conform, or does it satisfy the rule of the multiplication of matrix? That's my question. So it's a yes or no something. Does it satisfy the rule of multiplication of matrix? So,
Yeah.
in fact, you guys are making the thing difficult. I can't be teaching the thing always because I might be wrong somewhere, and you have to correct me. Because
Okay. So, are you saying that the number of columns of the first matrix must always be equal to the number of rows of the second matrix, right?
yes, yes. And I'm saying with the
Okay,
example
and you're
given,
asking that, yeah,
with the example
so far, yes,
given,
examples not them, the same as like any rule near.
and then if can we multiply matrix A?
No, we can't multiply matrix A by B.
Okay, so Balfour is saying no,
because the first one with the matrix A, the columns are 2, but with the matrix B, the rows are only 1. So there's no way we can multiply the 2.
one. I've not written anyone here.
Like I mean, we have only one rule. Yeah.
I wrote
Okay,
4.
let me come again. We can't multiply the 2 because with the matrix A, it has 2 columns. And
I'll specify the thing on top.
Okay, Myra. Okay, 1.
Okay, Nana, but I bet Charlie, Bram.
Myra.
Nana, bet Bram. Okay, so we are saying that
Yeah, me too.
we are saying that the number of rows, and I told you I've written it here. The number of rows are always like with the first one, that's the m by n, and the number of columns are the second one. So the rule is saying that the number of columns of the first matrix must be equal to the number of rows of the second matrix. Now, how many columns do we have in the first matrix? How many columns do we have? 4. Must be equal to the number of rows in the second matrix. This is the second matrix. How many rows do we have? 4. So can you multiply or not?
Yeah, we can multiply because they are the same.
Okay. So if you have something like this, so what is the dimension of matrix A? What's the dimension of matrix A? What is the dimension of matrix A, Charlie?
It's 2 by 3.
2 by 3. Dimension of matrix B.
They are the same, 2 by 3.
So can we add these matrices A and B? Can we multiply? Sorry, can we multiply them? Can you multiply
No,
them?
please.
You said
No, please. We can't multiply
because
the number of columns of the first matrix is not equals to the number of rows of the second matrix.
thank you. That's great answer. All right. So what about this one? I've done some alterations here. I've done some things. What about this one? Can we multiply? So what is the dimension of matrix B now?
2 by 2.
Can you multiply these two?
No.
Okay.
If I was saying now,
Jim,
hey, Charlie, hey, maybe send me download the Microsoft one. Microsoft Office. That's me lab.
can you multiply them?
Yeah, we can multiply. Yeah, we can multiply them.
You can multiply them. Now, so
Yeah.
be careful of the multiplication, like the process, how you multiply them. So A multiplied by B. Now, this one, you take the rule, the element on the rule, okay? Are you here?
Yeah, I'm listening.
You take the element on the row and drop it on what? The columns of the second what? Matrix. You get it?
Okay.
So you take the
Yeah.
horizontal aspect like this, the vertical, the rule of what? A matrix A, and drop it on what? The columns of what? The matrix B. So if you're having even 6 columns, you have to drop all the row here on the 6 columns here. So you take row here, you drop it on all the columns of the second matrix. So here, 1 will multiply 3, 0 will multiply 1, 4 will multiply 4. Plus the same 1 will multiply 5, the same 0 will multiply 6, 4 will multiply 7. So let's do that. So you bring your bracket, so it's 1 by 3. You are doing some products. Then plus 0 by 1. Plus 4 by 4. Then we take the same rule and drop it on the second column. So we have 1 multiplying 5. So you add
1 by 5.
1 by 5 plus what?
0 by 6.
0 by 6 plus
4 by 7.
4 by what?
7.
You perform the same thing for the rest. So we are done with the first one. So let's take the second rule and drop it on them. So let's start. And 6 by plus
Plus 7 by 1.
7 by 1.
Plus 1 by 4.
1 by 4. Okay.
6 by 5.
6 by 5
7 by 6.
plus 7 by 6
7 by 6. Plus 1 by 7.
plus 1 by 7. So you do the sum product. You perform the sum product. And that will be your answer. So 1 by 3 is 3 plus 0 by 1, 0. 4 by 4 is what? 16. 16 plus 3 will give you what? 19 here. Okay, so this one, 1 times 5, 5. plus 0 times 6, 0. So 5 plus 0 will give us 0. 4 by what? 27 will give us what? 28. 28 plus 5 will give us 33, right? Now let's perform this one too. 6 by 3 is what? 18. Plus 7 by 1, that will give us 25. Plus 4 by 1, that will give us what? 29. So let's start with the second one. 6 by 5 is what? 30. Plus 7 by 6 plus what? 1 by 7. And that will give us 79. So this is how you what? Perform your what? Multiplication. Now, we can use calculator or MS Excel to perform this one like within a second. Within seconds. You get me? Or within a second. All right, so this, you end the class here and continue some other time, probably Wednesday. All right, thank you for your time. Good night.
Thank you for sparing your time for us.
You're welcome.
God bless you.